Well, now let's take a look at another example. Example number 6. But before we do that, it's important for us to recall an important definition that we would have seen in a pre-calculus class. It relates to the idea of the absolute value. Now, we briefly discussed this in the video on the skills check, but let's take a look at it again. The absolute value of a real number x is actually, or can actually be communicated by a piecewise function. We know that absolute value bars have one specific job: to take any negative quantity and turn it positive. That's the goal. So notice that this piecewise function does exactly that. The absolute value of x is actually the same thing as x itself as long as x is 0 or greater, right? If x is 0 or positive, then you don't really need the absolute value bars, you can drop them. But if you know ahead of time that x is negative, then instead of putting absolute value bars on it to make it positive, you could also just multiply it by a -1, and it will become positive. So we're going to use this idea to help prove that this limit does not exist. Notice that much like up here in example 5, where we were asked to show why a limit doesn't exist, here we're asked the same thing. Our goal is really going to be to show what the limit looks like on both sides to confirm that the overall limit can't possibly exist. So let's go ahead and use this. So we'll say that we will check the limit from both sides. Okay, so we'll check one way. This will be the limit as x approaches 0. How about from the left? Now, if I know that I'm approaching 0 from the left, that is, if I'm working on the number line and I'm to the left side of 0, I'm over here, I'm working with only exclusively negative numbers. And so that would mean that if x is a negative number, I could replace x with the value, absolute value x with the value negative x, right? That's actually coming right here from this definition. Absolute value x is negative x if x is a negative number. But of course, once I do this, I can recognize that it's pretty easy to go ahead and simplify what I have here down to just -1. And what's the limit of -1? That's -1. Well, notice that we can also then check the limit in a very similar fashion from the other direction, that is, from the right. And here, what would I be able to replace absolute value of x with? Well, if x is approaching 0 from the right side, then that means I'm over here on the number line as I'm moving towards it. And that means that x is positive. And according to the definition up above, if the absolute value of x, if x is positive, I can just replace it with just x itself. And so this is going to become just the limit of 1. And the limit of 1 is 1. So what I end up seeing here is that I can kind of combine these two things and clearly say, so let me write it like this. The limit, the absolute value of x over x as x approaches 0 does not exist. The limit from the left side and the right side are different. And so I end up with this result. Not too bad. But this is an important thing to keep in mind when absolute value bars start to come into play, that a lot of times I can think carefully about if I have something that's positive or if I have something that's negative.